To photograph the planets, a telescope with a long focal length and a high f ratio are recommended. This particular telescope here is the Celestron 11-inch Edge HD. Now, it has a focal ratio of f10 with a focal length of 2,800 millimeters. That's a long focal length, but you need that to get good images of the planets. Also, a camera with a smaller pixel size is also recommended. Now, you can use other cameras with pixel sizes, say 3.6 or even up to 5.96. But this particular example here, I'm using a planetary camera, and most planetary cameras have a pixel size of about 2.9 microns. And I'm using the Uranus C, the Player One Uranus C camera on this venture for tonight. Now, the planet in question is the mighty planet Jupiter. Jupiter, the largest planet in the solar system, will be coming into opposition in about 2.5 weeks. January 10th, 2026 will be this year's, or this period's opposition time. That's when the planet is at its best viewing. That's when the Earth is between the sun and the planet. So we're seeing the planet at its best and its closest range as well. And I want to show you in this video how I capture the planet using this telescope and also the software that comes with the Celestron type mount. This is the CGX mount, and the software is called CPWI, and also a program called SharpCap. I'm also going to intertwine that with Nina. So SharpCap, Nina, CPWI, the telescope, the planet Jupiter. Let's do some photographing, and I want to show you how to do a time lapse using SharpCap. Welcome to Heavenly Backyard Astronomy. I'm Pat Procom.
Okay, wait till you see what SharpCap does in live stacking with this planet right here.
Now, if you chose this video, this is the long version. This is about 40 minutes long. Sorry about that, but there's a lot of information, a lot of good information packed in this little video right here. Now, if you don't want to go that long, I have a shorter version where I just cut to the chase, basically going into the animation features into SharpCap and showing you how to do that. That video is much shorter, but a lot of information is missing. So you can have your choice of the two. You can either pick this video or pick the shorter video. Anyway, let's talk a little bit about Jupiter. Let's go inside.
Now, in late December 26th, when I shot this video, Jupiter was rising about an hour after sunset, but over the course of the next 2.5 weeks, it'll be rising earlier and earlier, and then by the 10th day in January, it'll be rising right at the same time the sun sets. That's when it'll be at opposition. Right now, it's in the constellation Gemini, just to the upper left of the great constellation Orion the Hunter. And you can't miss it because right now it is the third brightest object in the sky. Venus is out of the picture. Usually Venus is the third brightest. What are the two other? Well, the sun is the brightest and the moon is the second brightest. But Jupiter is very bright. If you just look up in the east-northeastern sky, you can't miss it. So let's go into the computer and look at SharpCap, CPWI, and Nina. All right, I'm in the remote telescope computer right now, Telescope 7 I call it. And let's first of all load CPWI, and it's here somewhere. There it is, right there. Let's load this in first. This is the Celestron software to control the telescope using the CGX mount. And the first thing I got to do, obviously, is connect via USB. And it's connected. It's also looking for the StarSense AutoGuider and found it. I'm just going to do a quick align. That's all I need to do. Just say ready. Also, while I'm at it, I'll load the focuser, connect the focuser to CPWI, but just turn the focuser on. There it is. I have an automatic focuser on this system, so I don't have to worry about turning the knobs on the back of the scope and jiggling the scope. It's so much easier if you have an electronic, automatic electronic focuser on your system. Okay, everything's all set over here. I'll exit out of that. And the next thing I want to do, I'm going to go, first of all, full screen, show all sky. And there's Jupiter right there. And I'm going to just minimize this right now. I'm going to open up SharpCap. because that's the software I'll be using. Also, I might be using Nina, so I'm going to open that up as well. But let's just minimize this for now. Let's open up Nina. The C11 F10 planetary setup using the Player One Uranus C or Uranus camera, Uranus C color camera. All right, so let's load in the camera. There it is right there. Let's load it in. So let's see if it's in focus. It should be in focus. I'll just take a quick snapshot here. It should be pointing somewhere near the North Celestial Pole. And it's not. Okay. Do I have the dew cover on? Well, it does help to take the dew cover cap off, which I had failed to do. I just took it off, and let's take a look here now. And yeah, so we got an image here. Not quite in focus, but I got an image. So just bring this down. Let's focus this real quickly, because it helps to have it in focus if you're going to do a plate solve. All right. It's close enough, I think. So, okay, I'm going to, I'm just going to put this over here. So the next thing I want to do, go into here. I can do it a couple of ways. I'm going to do it this way for now. I'm going to go into my equipment, go into mount, going to connect the mount. And there it is. Mount is connected. That's all I need, I think. You're right. Okay. Close all. Let's go into imaging once again. Let's go to stop that. Let's go into planetary orbitals. There they are. And let's go to the Jupiter right here. Load in Jupiter. And it's just clearing my horizon, my tree horizon off to the east-northeast. So let's go into the framing mode. Takes about 30 seconds or less. Usually less than 30 seconds to set up the framing mode. And I'm going to tell CPWI to, I mean not CPWI, I'm going to tell Nina to go to my target. It seems to be a better, doing a better job at it. I think I knocked the alignment out on my StarSense auto guider, so I can play with that later. But make sure all these are off so I don't have to compete with that right now. And go back over to here and go slew and center. All right, so it's going to slew to the center. Hopefully it's in somewhat decent focus by the time it gets there. I'll run an autofocus very shortly, but with planetary, you just have to be close because you're going to have to play with it anyway once you get to the planet, because looking at atmospheric conditions, that's very important to know you're seeing and so forth. As a matter of fact, I'm going to pull that up right now as well. The seeing conditions, because it's not only at the surface do I have clear skies, but I'm going to have clear skies over. So let's take a look at the seeing right now. Let's go into my savannahpat.com webpage and go into computer models, go into the upper dynamics, go to 250 millibar winds. I'm right here. As you can see, the winds are very light across my region, even up to around 35,000 feet. So if I'm up here in the north, around North and South Dakota, Minnesota, anywhere up in the north there, those winds are riding about 130 to 140 knots. That's about 150, 160 miles an hour. That's going to allow a large amount of disturbance in the atmosphere. But here I got very little motion in the atmosphere, so I should have some fairly good seeing in the atmosphere. All right, let's take a look. Well, there's Jupiter right over there, so it's pretty close. So I can let's go to try to redo it again. Okay, let's see if it gets it right on Jupiter itself. And it's exposing. Let's see what it looks like. Well, again, it's close, and it's gotten so bright now that it can't solve the problem. So, but that's okay. All I need is have it close. So I'm just going to hit stop over here. Now, the next thing we're going to do, go back up to equipment. I'm going back up to the camera, and I'm going to disconnect the camera from Nina. All right. Now I'm going to minimize Nina. I'm in the ballpark. It's all I need to be. You can close out that. and go back into SharpCap Pro. SharpCap, I mean, this program has gone so far over the last several years. It's amazing, particularly for planetary and also for the deep space now too, for this live stacking routine that it has. All right, let's go into the cameras. Let's find it. There it is, the Uranus C, the IMX 585 camera, the player one. Yeah, look at that. There it is right there. And it's pretty doggone close into focus right now. But let's go into, back to CPWI. Let's go into the telescope. Let's go to slew controls. And let's bring that up, just bring it over here. While I'm in here, I found out this is very important if you're going into do some planetary versus deep space. You want to make sure the telescope is tracking in the correct mode. So go into here, go into configure mount, and then go over into tracking rate. And I have it set to, you have it set, usually it's on sidereal. That's for deep space. That tracks the stars. Or you can track the moon. But if you're doing planetary, you want solar system objects. So planetary is what you want solar. So click on solar. And then come down all the way down to the bottom here, scroll down and say accept. All right, so now it's going to be tracking with the planets. All right, next thing I want to do, slew controls. I'm going to bring this back down a little bit because number 9 would be way too fast. And I think this is left and right is left. Yeah, bring it over. And yeah, it's going to have to stabilize somewhat. Whoops, up is down and down is up in this case. Now, after the meridian flip, that'll be just a little bit different. So go back over here. I want to get it in the center, so let's just put the reticle on. Where are you? I think that's right there. All right, let's put it in the center here. It's going to take the mount a little bit to stabilize. Once it stabilizes, it'll be fine. On this mount, my CGI mount, I have to, CGI? CGX, going into computer graphics interface. Anyway, CGX, it takes about 12 to 15 seconds for that mount to stabilize after a slew. So particularly if you're slewing in one direction and it wants to stabilize in the opposite direction. Anyway, there it's stabilized now. All right, so I can turn the reticle off. That's just, well, no reticle. Okay. All right. So the next thing I want to do, I could just keep this out of the way for right now. If you're into SharpCap, first of all, you want to make sure the planet looks something like this. Hang on, let me zoom in a little bit here for you. And all right, so you can see I'm a little bit out of focus, but we're going to play with that in just a minute. But you also want to come down to the image controls, and you could go with auto. And you might want to, let's tell you what, let's just leave it on auto for right now. And that's going to be a little bit of a greenish, reddish hue to it. All right, let's play with the focus now. So you can see it's, particularly on the edges, you can see it's a little off. However, as I'm right now set this, I have the settings at 10 milliseconds. That's very, very fast. I'm getting 36, 38, almost 40 frames per second. And this is at a full screen, so hang on a second. All right, so let's just bring this up and see if we can see the moons. And I found it's easier to focus if you focus on one of the moons, particularly the two brighter moons, Io or I think it's Ganymede. So let's just bring this out just a little. Well, this is good. Let's go this way. Is there another moon out there somewhere? There should be 4. Oh, that one's behind the planet right now. Okay. Anyway, let's focus in on this moon, these guys right here. So let's just play with the focus and let's go with it. I'm still getting a lot of atmospheric diffraction because it's kind of low in the atmosphere. It's about 35 degrees up right now. Let's just play a little bit more here. So I'm working on these two guys right here. I could work on that one too, but again, this is a lot easier with an electronic autofocuser because every time you touch the focusing knob on the telescope, the thing jiggles. You have to wait for the jiggling to stop. But with the automatic focuser, it doesn't jiggle so much. I think that's going to be pretty good. Let's bring this back down to 10 milliseconds. I'll just type it in, a lot easier. Okay, and there's Jupiter. Yeah, now if you look at the edges, you can see it's a lot less fuzzy. You can see the banding already in the atmospheric belts. Now the red spot is it's behind this curve here. It's still about an hour or 2 hours out before the giant red spot shows up. So I think that might be pretty good because I want to get the moons as well. All right, let's go back to the full view, which is auto. There's the full view. That looks pretty good in itself without the SharpCap. Wait till you see what SharpCap does in live stacking with this planet right here. Okay. Again, I'm going to pull it out of the, not focus, I'm going to pull it out of the gain. I'm going to bring the gain up. Let's just, see, yeah, 250. Let's just bring it up so I can see. I want to see the moons. All right, so I want a frame kind of like in here because I want to track the moons because we're going to build an animation in this. So I want to track the moons. All right, so now what I like to do, first of all, in this, for some reason, I think it does better in RGB. You have the options of raw 8, 16, or mono 8. Or RGB 24. So I'm going to use RGB 24. And the region of interest, I'm going to probably take it at the 1024 by 768. Let's see what that is. And no, that's too small. I got to go a bit bigger. All right, let's go with 19. Well, let's try 1280 by 1024. Okay, they're in there. Of course, now the bigger the frame is, the slower the frame rate's going to be. But I want to get these moons. I tell you what, let's push the planet over a little bit, but I don't want to use it with the slew. I'm going to just use it with the region of interest right here. I can move this around, see, and with the mouse, or I can fine tune it with the pan and tilt. Tilt is up and down, pan is left and right. Let's just go a little bit more left. Okay, a little bit more right. Let's just do it there. I'm assuming these guys are coming in. This one's going in as well. Hopefully, we'll see. All right, let's bring it back to 250 on the gain, analog gain, 250. Okay, there's a beautiful picture of Jupiter. All right, so let's go into the magic over here, and let's type in not live stack, but planetary stacking right here. Start stacking frames for deep sky imaging, and in this case, planetary. And they're already starting to stack. And I can adjust the values over here in the stacking. And also I can adjust the sharpening. If you want to, first time you're through it, you can click on the Get Started tab, and it gives you some things to do and so forth. Small planet, large planet, like in this case, solar, partial solar, lunar, and so forth and so on. Excuse me, and so on. But look at already, this is it's picking up the moons. There it is. All right, so it's picking up the moons. So, so we'll go into frame filtering. That's important now. What I have it set here is I am accepting only the best 15% frames. So all that atmospheric dispersion and what else is going on, because it's still kind of low in the elevation. I'm filtering out a lot of that. So I'm getting most of the frames being filtered out, but if you look over here, it's stacking. I've already got 500 stacks. And I told it to go ahead and stack up to 3,600 in this particular example. While we're doing that, you also have, I'm going to skip this for a second, the time lapse. Let's go into stabilization alignment. And this case, it's a planet full disk. All right. Now, if you're shooting the moon, obviously you click on surface. If you're stacking mode, I want to do a multi-point stacking. If it's a smaller object like Neptune or Uranus or Mercury, you'd want to use a single point. But any of the larger planets, Mars, Saturn, and Jupiter, and Venus, you want to go full disk, all right, and go multi-point. And then you can go show alignment points right here. And these are the alignment points that it's looking at. So it's not looking at the moons. So it's going to keep this portion of the view in the center of the object that it's stacking. Okay, and even if the planet drifts left, right, up, down, it will put it back here right in the center, and which is going to be really good for when you're doing the animations. All right. If you want to look at the alignment points, the smaller the pixel, the more points you have. The larger the pixels, the less points. So I'll give you an example. See, let's go with, let's say, for example, 112 pixels. You only got 5 points to stack with, it looks at. So let's bring it back down to right there. Now, of course, once you change that, you clear the stack. You reset the stack. So I'm starting over once again. Okay. So I just leave this at 4, and contrast threshold, I leave that at 1.5, whatever. And track planet with SharpCap selection area, track planet with camera region of interest, which we're doing, and also realign color channels. That's a question that you might want to, an option you might want to play with, either one or the other. It doesn't do much at, well, you see, it does. It does. Okay. Let's turn off the alignment points. I mean, they're still there, but if I realign the colors, well, once it's stacked, it doesn't really make much of a difference there. Okay. And overlay current frame outline position. I really don't see much of this change. Okay. You can rotate the image if you want. You can flip it. See? Or you can rotate it 90 degrees to the right or 90 degrees to the left. And I'm just going to go back with none. Take the raw view from the camera itself. Okay. And of course, you can also do it this way too. You can flip horizontally or flip vertically. So that's that. All right. I don't know which way is up or down in this actual position with the camera that I'm using. However, I think it's right, but once I get a few animation frames in, I'll know exactly how the alignment should be, whether it's rotating to right, which would be counterclockwise, which is the correct way, or if it's rotating to the left, then means it's rotating clockwise, which we know is not right. So counterclockwise is the way you want to go. So you want it, for example, if the red spot is over here, you want it coming across this way and moving across the planet surface that way, because all planets rotate counterclockwise. All right. Okay. All right, I'm approaching 5,000 frames now, and it's looking pretty clean at the moment. Also, you can look over here in these buttons down here. Show unprocessed frames right there, unprocessed frames, and there you can see the actual planet itself. If I click on that, that's the stacked images, and with the image sharpened and colorized. Also, if you look at half and half, this shows the two side by side. You can see how the live planet versus the stacked planet are aligned with each other. And you can see it's guiding really well with the CGX mount in the solar tracking mode. So we just hit 5,000 frames. So I'm going to hit this, and then I'm going to go over here, save as a 16-bit TIFF file. I'll just do that, and it saved it right there. All right, and if I want, I could, I think 5,000 is the max. Can you go? No, you can go up to, thing about Jupiter, it rotates so fast that you really don't want to go too long with the stacking process because again, the rotation of the planet is just under 10 hours, so it's really fast. And so you're going to get a blurring if you go too long. So what I also did while I was in the waiting to get to 5,000, I went to frame filtering. I jumped that up to 25 frames, take the best 25 frames, 25% frames of the images and so forth. So it'll stack faster because, again, if you take too long stacking, you're going to start blurring the image, again, because the planet is rotating so fast. All right, let's just take while it's doing that, let's just take a peek at the images. Where are we at? SharpCap files right over here. Here we go, December 26th. There's the image right there that I saved. I mean, that's not bad. Not bad. It's a little fuzzy still, again, but it's low on the horizon. Let's take a look at Nina. Look at the framing. And you see right there, it's still only 33 degrees above the horizon. So I like it when it's at least 45 for planets, 45 degrees above the horizon. I know if you're up in the northern latitudes, you're not going to get this 80 degrees transit elevation. I'm here at 32 degrees north latitude. So if you're up in the England or whatever, you're only going to be at about 50 degrees transit. 30 degrees from 60. You might get up to 60 elevation, 60 degree elevation. All right, let's go back to the SharpCap, and I'll stop blabbering here, babbling. SharpCap, come on, bring it up. There we go. All right, I'm going to bring this back down now to 15%. Right there. Do filtering of the shows. All right, let's just zoom in. I could zoom in here. We got to... let's just go 150, take a... See, that looks pretty good. All right, let's bring this back to normal size. All right, let's go back into planetary stacking to here. Yeah, that looks pretty good. Okay, let's see if I can get the moons. Let's bring up the... I think I have it over here, my bookmarks. Jupiter, JavaScript Jupiter, and yeah, I got it right. So there's Europa, Ganymede, and Io. Callisto's way over there to the right out of the picture. So yeah, there's Europa, Ganymede, and Io right here. So if I go, I'll put the link to this little JavaScript on here. Well, it's shallowsky.com Jupiter. Okay. Let's see. Let's advance an hour. Look around here, right here. Advance an hour. So Europa is moving away, but Ganymede and Io are moving in. And I don't see the red. There's the red spot right here. So it's way over there. It doesn't show up until, oh gosh, another 2.5 hours, 3 hours from now. We got the frame filtering at 15% of the best frames are going to stack. And then I'm going to the stabilization alignment. And just to review here, I'm using a full dist on a planet. I got alignment pixels, spacing 64 pixels. So it's a tight framing. If you look at the alignment again, there's the framing right there. And so it's going to keep this disk locked right here in the center. And I got the track planet with SharpCap selected area, track planet with the camera region of interest, realign color channels. That's a choice selection there. And we're going to leave the image alone because we know it's correct. All right. So let's now get going into time lapse. So let's build a time lapse. And let's take this down to, well, you can set it at 2500. Whatever this gets to, the stack length, I'm going to stack it every 2 minutes. So however many frames it gets in 2 minutes is what it's going to stack with. So it's going to be about the same each time. As it gets higher up in the sky, actually, I'll probably get a little bit more image stacked than is at the lower altitudes, because you get a better image at higher the altitude. You get less atmospheric diffraction going on in. Now, I'm going to save it as a TIFF image. You can save it as a PNG image, or AVI video, or SER video, or a WMV video. However, I found out you're better off, in my opinion, if you just make a either TIFF image or a PNG image. And if you have a your own editor, like I have, you can then re-edit the animation when you're done. Or you can also do this. Click on this little check mark here, create short animation GIF file or GIF file when completed. And it'll give you 2 different files, one forward and one going forward and backwards. That's kind of neat. So I'll show you that at the end of the video as well. So I'm going to reset the stack after every image. So in case there's any artifacts that show up, like around here, I'm close to an Air Force base. An airplane passes overhead, leaves a big old streak across the image that will destroy the stack. So I have it, after every image, I have it to reset the stack back to 0. So I get a clean stack every time. All right, so once again, in 120 seconds is the maximum you can stack at. You can stack lower, but you can't stack any higher. You can't stack any higher than 120 seconds, which is what, every 2 minutes. Now, if you really want a smooth image, you can lower that down to a minute or even 30 seconds. But then again, you're going to have less stacked frames. But with Jupiter, you don't want to go too much longer than 2 minutes. Now with Saturn, you can go much longer if you wanted to, but you can't because you only get the option of 2 minutes. Mars, again, it rotates almost the same speed as the Earth. Mars is just a little over 24 hours. But Jupiter at 9 hours, 7 minutes, something like that. Just under 10 hours. So it's really flying through. As a matter of fact, if you look carefully, you can see the equatorial area is a little bit bulgier at the equator than it is at the poles. Because of that fast spinning rate, it bulges out the equator somewhat. All right, so let's quit babbling and let's start time lapse. As soon as I hit start time lapse, the stacking length here is going to go back to 0. So before I do, let's just take a quick picture, look at the unprocessed frame. See, the mount is guiding perfectly. So, all right, so let's hit start time lapse and let her rip. All right, and it's going to be counting down over here how many frames you have and so forth. It just recorded the first frame as a stacked, and then from here on out, it's going to start adding. Also, there's another here. Oh yeah, you have these other options to play with. You can put add a timestamp on the top. We can do that. Add that. Well, you can't add it once you start. You can't change these things, but you can add a timestamp to the image if you want to. Each frame will have a timestamp. And I also clicked on Save an Extra Time-Lapse File with the Unsharpened, Unadjusted Image. That's this one right here. So it'll save that image, and it'll save that image, the stacked image and the raw image. So you can use that as to compare. Really, in my opinion, you don't really need the extra image because it's just going to take up space and you're just going to end up deleting it anyway, unless you had something, get off my screen, unless you had some artifacts that messed up the image and so forth and so on. But there's the, what did we say that was? EO or IO and Ganymede, and that's Europa over here. Okay, and the red spot is somewhere on the back side, somewhere around here on the back side, so it's got to come around and then start going this way. So the planet should be rotating this way. Okay, so these guys are coming in. Europa is going away. And Callisto is way over here, somewhere off the screen. I have some clouds pushing into the area now. I already got 5 frames added, but looking at the satellite imagery right here, I am located right about here. And there are some clouds passing in across my area, so that's going to cause some problems. And then I'm beginning to see some more clouds coming in from the west, so I might not get a full night's view out of this system this evening from this, but you're getting the idea how to do this anyway. So let's minimize this, go back at the planet itself. And I'm losing Ganymede and Io, and I can barely see Europa over here because those thin clouds passing overhead, and that's causing the planet to blur somewhat here. Let's go back to the stacked frame right there, and there you can see the Ganymede and Io and also Europa over here showing up in the stack. But I'm not getting the best of stacks. But let's take a look at the stacks anyway. And let's bring those up right now. There are the stacks so far. These are the images of the stacked every 2 minutes, and these are the raw images over here. So let me bring this up here. Just go full frame, make it a little bit bigger for you. And we go 5 frames. You can see now if I have it correct, it should be rotating from the left to the right. In other words, counterclockwise. So let's see. Yeah, it's rotating counterclockwise, all right. And that's the last frame there. There's the raw images there. You see how it bounces around? But with the stacked image in SharpCap, it keeps it locked in the center, which is kind of neat. Also, let's see if we can see that if the moons are moving. Europa they all should be moving from here to this way, because Europa is moving out away from the planet, and the Ganymede and Io are approaching the planet. Let's see if that's true. Yeah. There they go. See, and I got a little fuzzy there because that cloud's coming in, okay? All right. Let's close that off. All right, let's bring that down here. And there's a stack. See, I'm not getting very many stacks right now. There it goes. Little patches of thin, wispy clouds are passing over the target. So that's messing things up a little bit on this evening. So I don't have the best clear skies, even though above the atmosphere is quite quiet. So that helps. If I can get more clear skies, I'll get some really good, clean pictures. But I don't think I'm going to get much after about midnight tonight. Those clouds off to the west are going to make it in this way. Maybe. Maybe not. So here's the saved picture of the planet with the moons. You can see on to the right Io and Ganymede, and to the left Europa. And that's a good looking picture. And this is a picture here from the 2 nights before. I had a clear sky. I took Jupiter, and you can see the giant red spot. You know, that giant red spot is so large you could fit 2 Earths in it side by side. But there's the great red spot there. Now, I want to show you the GIF animation, or GIF animations, and this is the image from 2 nights ago when I had clear skies, and there you can see the animation of Jupiter, and definitely rotating. You can certainly see the belts and everything rotating cleanly. And this is the other GIF file that it makes, and it's forward and backwards, forward and backwards. It goes forward, then it goes backwards, and then so on and so forth. And they're kind of neat. You can really put these up on your websites or your social media pages too. Anyway, and this is the animation I made taking the raw TIFF files that I saved, and I put them through the editor I'm using right now to record this, and made this animation here of Jupiter. Well, I tell you what, it's amazing.
I got to tell you, in the past, I had to shoot the AVI files or other video files, and then go over into auto stackered and then process the video from there to get an image, and then from there I had to go into Registacks to process the image after that, and then after that going into Photoshop to polish it up even more. Basically, SharpCap, the new version right now, is doing all that, putting all those other programs to rest. So really all you need is the software is SharpCap to get these fantastic images and the animations. Watching Jupiter rotate, it just blows my mind. And seeing the moons moving in and around their orbits, I just wish I had a longer period of time. The clouds moved in. I have a video I showed you also from a couple nights before where I did have a longer night's view, and the animation of those are coming in right after this. So thanks for watching. I appreciate all those who have been supporting my channel, and my members. I really appreciate that, and you could click the membership if you'd like to join my channel or support my channel by sending me a super thanks or looking into my Patreon page or buy me a coffee. Anyway, the planets are, well, Jupiter is coming into full view. Mars is getting out of the picture now. Mercury is low in the evening sky, and Saturn is low in the southwest at sunset and basically moving out of view. Venus is just about behind the sun right now. It'll be coming out as the evening star sometime around February. Then going into the spring months, we'll be seeing Venus. And I'm excited to see how this stacking program works with the planet Venus, because Venus is extremely hard to photograph, but I'm excited to see how the new version of SharpCap will handle the planet Venus. So remember, the heavens are filled with majestic objects. Not only the planets, but the nebulosity, the galaxies, the star clusters, all that up in a sky near you. So unless you need rain, clear skies, everyone.